All right, let's talk about one of the sneakiest, most destructive bugs in the history of computers. It's a tiny, tiny digital mistake that has cost billions, brought the internet to a standstill, and, yes, even blown up a rocket.
So here's the question for you. What on earth could a state-of-the-art $370 million rocket possibly have in common with the first major internet worm? I mean, one is a marvel of engineering, the other is a piece of malicious code. They seem like they're from different planets, right? But believe it or not, they were both brought down by the exact same, surprisingly simple problem.
And the answer? It all comes down to one tiny digital spill. A single moment where a piece of data just got too big for the little box it was supposed to be in. We call this an overflow, and it's like a hidden crack running through some of the most important technology we use every day.
Okay, so what is this digital spill really? The concept itself is actually super simple, something anyone can get their head around. Let's break it down. You see, in programming, every piece of information, every number, every bit of text, gets stored in a little digital container that has a fixed size. An overflow is exactly what it sounds like. It's what happens when you try to cram too much stuff into a container that's just too small. The extra data has to spill out somewhere, and when it does, that's when things go sideways fast.
Let's make it even simpler. Imagine you've got a little candy box, and it's designed to hold exactly 5 pieces of candy. Now, what happens if you try to shove 10 candies in there? Well, they're going to spill out, right? In a computer, that spillage doesn't just make a mess on the floor. It spills into the next box over, corrupting whatever data was in there and causing total chaos.
And that digital chaos? It can have some pretty spectacular real-world consequences. So let's look at how this abstract idea led to a very, very literal explosion with the doomed flight of the Ariane 5 rocket.
The specific bug we're talking about here is called an integer overflow. It's all about numbers. Think about a car's odometer that only has 5 digits, so it goes up to 99,999. What happens when you drive one more mile? It doesn't just break, it wraps around and resets to all zeros. Well, in a computer, when a number gets too big for its container, it can do the exact same thing, suddenly turning a huge positive number into a small or even a negative one. And as you can imagine, that really confuses the system.
And the price for that confusion? A cool $370 million. That was the cost of the rocket and its satellite cargo, all of it. Just gone. Vaporized. All because one single number got too big for its box. It's just a mind-boggling price to pay for what was essentially a typo in the code.
And the crazy part is how fast it all went wrong. The rocket takes off, everything looks perfect, but just 37 seconds into the flight, a piece of old code, recycled from the previous, slower rocket, tried to cram a big 64-bit number representing the rocket's velocity into a tiny 16-bit space. It just didn't fit. It overflowed. This immediately crashed the guidance system, which started sending complete garbage data to the main flight computer. The computer, thinking the rocket was suddenly tumbling out of control, did the only thing it was programmed to do in that emergency. It triggered the self-destruct. The whole disaster, from error to explosion, took about 3 seconds.
So we've seen a physical explosion in the sky. Now let's pivot to a digital explosion that spread across the entire planet. This is the story of the buffer overflow, which is a favorite trick of hackers and the engine that powered some of the most infamous computer worms in history.
So a buffer is really just another name for that temporary memory candy box we talked about. But with a buffer overflow, the spill isn't an accident. An attacker does it on purpose. They deliberately send way too much data to that box, but they're not just trying to make a mess. No, they are strategically overflowing it to overwrite the memory in the box next door with their own malicious code, hijacking the entire program.
And this one single flaw, man, it has been absolutely devastating. Back in 1988, the Morris worm used a buffer overflow to bring about 10% of the entire internet to its knees. Then, more than a decade later, the Code Red worm used a very similar trick to infect almost 500,000 servers, causing billions and billions of dollars in damage worldwide. It's the same fundamental mistake exploited over and over again with catastrophic results.
So how did the worm even pull this off? Well, it's almost embarrassingly simple. The program it attacked was using a command that was notoriously unsafe. Its entire job was to accept data from the outside, but here's the kicker. It was built without ever checking the size of the box it was filling. It would just keep stuffing data in no matter how much you sent it. It was a huge, glaring security hole that the worm just waltzed right through.
So you've got a rocket blowing up and a global internet crisis, and both of them come from the same basic kind of error,
It really makes you stop and think, what does this tell us about the digital world we've built all around ourselves?
When you boil it all down, the lessons are pretty stark. First, the tiniest coding mistakes can have absolutely colossal consequences. The Ariane 5 disaster shows us that reusing old trusted code without rechecking it for a new situation is just asking for trouble. And the Morris worm proves that one simple, lazy programming habit can become a massive security threat to everyone. They both shine a big, bright light on a hidden fragility that's woven into the very fabric of our modern world.
And that leads us to a final, pretty unsettling thought. We've seen what one simple type of overflow can do. It really makes you wonder, doesn't it? As our lives get more and more tangled up in billions of lines of code, what other simple, forgotten errors are just lying there, dormant, waiting for the wrong data at the wrong time? What other digital candy boxes are just about to spill?